So good morning. So we have to discuss or continue our session. The current electricity, very important topic. So just now we have discussed so many problems. We went through the question. The problem comes in the current electricity. If you understand the topic, very easy to understand it. So first one. Here, the last class you have seen Wheatstone's bridge and the application of Wheatstone's bridge, measurement of current. So today we can pass on to the moving galvanometer. The moving galvanometer will see in detail in the effects of current. That is called magnetic effect of current. Before that, I have to correlate this unit for this current electricity because the measurement is very important. The current can be measured using ammeter. Ammeter, I already discussed that it is not a direct instrument, only it is a calibrated one. What is a direct instrument? The moving coil galvanometer or tangent galvanometer is a direct instrument. In the moving coil galvanometer, a very high resistance connected parallel, it becomes an ammeter. The parallel connection is very important. So just a circuit diagram I have given. This is a moving coil galvanometer. Galvanometer is more sensitive instrument. So I bypass the resistor here. So this is not Rg. So kindly correction. It is Rs. So I consider the resistor in parallel. That is called shunt resistor. Therefore, the incoming current branched into two. Ig is the current through galvanometer. Is is the current through shunt resistor. Therefore, the total current I is equal to Ig plus Is. So, this is the thing. So, if it is a thing, what is a thing? Here the resistor connected in parallel, we have discussed earlier itself, the potential difference is always constant. If it is series connection, current is constant. If it is parallel connection, potential difference remains constant. Therefore, potential difference between this end is equal to potential difference to that end. Therefore, the current at this end I minus Ig into the resistor Rs is equal to current through the galvanometer that resistor. Therefore, the shunt resistance can be calculated by using the formula Ig by I minus Ig into Rg. So many problem comes in this area. Be careful. The repeated problem. The ammeter and voltmeter, calculating the shunt resistance, repeated so many problems asked in the NEET examination. The resistance of the ammeter, because both the resistors are parallel, 1 by R is equal to 1 by Rg plus 1 by G. So that is the thing we have to think. Ammeter is connected in series. So the moving coil galvanometer, a high resistance connected in parallel, become an ammeter. This ammeter should be connected series to the any circuit to measure the current flowing through the circuit. That is the thing you have to understand it. Because inside it the resistor is parallel, the entire instrument should be connected in series through the galvanometer. Therefore, Ig by I. So, fraction of current through the galvanometer, Ig by I is equal to Rs by Rs plus Rg. This is important problem. Ig by I is equal to the ratio of current is equal to ratio of the resistor Rs by Rs plus Rg. Why? Because Rs plus Rg, these are reciprocal. That is the thing we have to study. Rs plus Rg. That is Ig by I. Ig by I is equal to Rs. This is a resistor. So we have to understand this is so many problems asked in this ratio of the current in respect of resistor. There is a ratio connected in series and parallel I have given the previous chapters, kindly went through it. So how the resistor connected, how the moving coil galvanometer can be converted into voltmeter. Voltmeter is an instrument used to find out the voltage. The same argument, take a moving coil galvanometer through which a high resistance connected in series. That low resistance connected in parallel become an ammeter. Here the moving coil galvanometer, very high resistance connected in series become a voltmeter. Therefore, R, G and R, The resistance potential difference, a moving coil galvanometer is in which a high resistance is connected in series. Used to increase the range and reduce the error. Therefore, voltage, we know V is equal to IR. So, the current through the galvanometer, therefore Ig into the total resistor. Since they are connected in series, we have to add up R plus Rg. Therefore, general formula from which R can be calculated, V by Ig minus Rg. It is connected parallel in the circuit. Since the resistor in the moving coil galvanometer series, the entire instrument should be connected parallel. The voltmeter always connected parallel to the circuit. Inside it, series. Ammeter is always connected series to the circuit. Inside it, parallel. That is a thing we have to understand it. Potentiometer. So just like our previous meter, the potentiometer is a separate principle. Potentiometer is an instrument used to find out the potential difference, and also it is used to find out thermo EMF, used to compare the EMF, compare the resistors, so many things. What is the difference between the meter bridge and the potentiometer? The potentiometer 10 meter wire. The 10 meter wire is there. A common jockey is moved. What is the principle of potentiometer? V is equal to IRL. Be careful. The principle of potentiometer, V is equal to IRL. R is the resistance per unit length. Therefore, the total current I into R is always constant. Therefore, V proportional to L is the principle. What does it mean? If more potential difference is there, the balancing length is also high. That is a principle. How to compare the EMF of the two given cells? So the same circuit, we know the previous thing, the primary circuit is always there. It is connected to a battery and a rheostat and a key is connected. So here we have to connect the potential difference. That is a thing V is equal to IRL principle. Here we have to take the DP-DT switch. There are 4 6-way key. So from which the galvanometer, high resistance, jockey is connected, from which a cell to be compared is connected. If the jockey is made to contact with the E1, jockey is moved to from the position A to B at a particular position J, the galvanometer shows zero deflection. That means the balancing length E1 calculated as L1 by the principle E1 proportional to L1. Similarly, the key is made contact with the E2. Therefore, by the principle E2 proportional to L2. Divide these two, E1 by E2 is equal to L1 by L2. Also, it is useful to find the internal resistance of a cell. So, similarly, it is also useful to find out the compare the resistor. If it is E1 by E2 is equal to L1 by L2, similarly, R1 by R2 also L1 by L2. The similar procedure. The internal resistance how can be calculated? Between the terminal A and B, a battery and a key is connected. So A2 is connected to the cell whose internal resistance to be calculated is connected. The thing. The first one is called, if it is connected without internal resistance, E by V is equal to I by I dash. E is equal to, we have discussed the internal resistance of a cell, R plus R by R, therefore R plus R by R. Therefore, small r is equal to I by I dash minus 1 into R. This is a formula to find the internal resistance. What is I? The first current, I dash second current. So we need not worry about it, the external resistance and the internal. Simply we can use, there are two. That's it. So this completes your current electricity, and we have to discuss some problems now. The current electricity, we have to understand the topic well. As per the current electricity, just for your consideration, we can consolidate the topic. From the first one is, the movement of electric charges is called current electricity. In the chapter, we have started with so many definitions. Okay. So in the current density, what is the definition of current? What is the definition of current density? What is the difference between current and current density? Current is a scalar, current density is a vector. How the direction of the current can be calculated? The direction of the current can be calculated only conventional direction. How the conventional direction may be there? So many things we have seen. The conventional direction, once we know the conventional direction, we should know the EMF. What is called EMF? Electromotive force. It is a work done in moving a electric charge from one end of the conductor to the another end. Like that we have to find out. So that after that only, what is the thing, the relation between the current and drift velocity? What is drift velocity? What is the relaxation time? After that only we have seen the Ohm's law. Some circuit obey Ohm's law. They are called ohmic circuit. Some other circuit doesn't obey Ohm's law. They are called anohmic circuit. Like that we have seen. Why I am saying it? Not to solve problem, you have to recollect the topic better for solving problems. The ohmic circuit, we are getting a linear curve, a straight line. We have seen, kindly recollect our previous classes. In anohmic circuit, there is a curvature, there is semiconductor and a transistor. They won't follow Ohm's law. There the resistance is called dynamic resistance, here ohmic resistance. R is equal to V by I, the delta V by delta I. That is the thing. So what is specific resistance? The specific resistance plays an important role. As far as the specific resistance is concerned, it does not depend upon length and area. It depends only on material of the wire. Resistance alone depends upon length and area. If length of the wire may be increased or length of the wire may be contracted, we have to see or we have to concentrate. The thing is there. When length increases, area decreases, but volume remains constant, though that when the wire is extended, the total resistance N squared R. If the wire is contracted, R by N squared. Like that we have derived, the thing is there. Then resistor connected in series, resistor connected in parallel. If it is series, simply we can add R1 plus R2. If it is in parallel, we have to take reciprocal. 1 by R is equal to 1 by R1 plus 1 by R2. Like that we have seen. Are you clear now? So, the two resistors are more resistor. Then we have to parallel to that of cells also. Cells connected in series, simply we have to add up. Cells connected in parallel, the resultant value remains the same. Then the Ohm's law is a conditional law, may be utilized for some circuits. So in order to get open circuit or any circuit, we should depend some other law. That law is called Kirchhoff's law. Kirchhoff's law, the two statements we have seen, algebraic sum of the current at any junction is equal to 0. The algebraic sum of the product of current and resistance is always equal to algebraic sum of potential in the circuit. Like that we have seen. Very clear. So the application of Kirchhoff's law, Wheatstone's bridge, P by Q is equal to R by S. The application of Wheatstone's bridge, meter bridge, it is used to find out the unknown resistance, specific resistance, and also temperature coefficient of resistance. So like that, how the moving galvanometer converted into ammeter, how it is converted into a voltmeter, what are the relation there. Then only the potentiometer instrument used to compare, just now we have seen. So many ideas why I am telling, why I am recollecting all these things in order to solve problem is better for your understanding. So here the current density problem, the very first problem, a copper wire is stretched to make it 0.1% longer. What is the percentage in increase in resistance. What is the percentage increase in resistance? So how can you solve it? A copper wire is stretched to make 0.1% longer. So the length of the wire increases. What is the percentage increase in resistance? So whenever the length increases, the resistance also increases. That is a thing. We know the resistance directly proportional to length of the wire and inversely proportional to area. R is equal to rho L by A. This is a thing we have seen. What is rho? Rho is a constant known as specific resistance. Am I correct? R is equal to rho L square by B. Why I put like that volume? Because we know volume is equal to area into length. Therefore, area is equal to volume by L. So this A can be replaced by V by L. Therefore, L goes to the numerator, L squared by V. Here V is called volume. Volume is area into length. Why I put into volume? Because volume remains a constant. So here rho constant, V is also constant. If I have this problem or this formula, if L changes, A also changes. So there are two variables. So here only one variable. So I convert the formula according to the question. So what happened here? Therefore, increase in resistor delta R by R is always equal to rho. We list bother about rho and V because both are constant. Only L square. That is 2 times L into L. Therefore 2 times change in length divided by 100. Why be 100? Percentage increase. Therefore 2 into delta L by L into 100 or delta L by L into 100. That is into percentage increase. Delta R by R, change in resistor, percentage into 100. 2 times because length L square. 2 times delta L by L into 100. That is 2 into, what is a delta L given? A copper wire stretched to make it 0.1% longer. Therefore, 0.1% into 100 into 100. So 2 into 0.1. The answer is 0.2%. So if the wire is stretched to 0.1%, its resistance increases to 0.2% because L square. Delta L by L into 100. So simply the value is given, we can put. Here the value is given in terms of percentage. 0.1% means 0.1 by 100 into 100. This is the procedure. Are you clear now? So there is an increase in resistance in terms of percentage. The second problem, a wire has resistance of 2 ohm at 25 degrees centigrade and 2.5 ohm at 100 degrees centigrade. Find the temperature coefficient of resistance of the wire. So this is also we have discussed in the temperature coefficient. The resistance depends upon the temperature. When the temperature increases, resistance also increases. By having the formula, we know RT is equal to R0 into 1 plus alpha. Where R0 resistance at 0 degree centigrade, RT is the resistance at T degree centigrade. So our question, there are two temperatures are given. First at 25 degrees, second at 100 degree. So this equation can be modified as the first question, resistance at T degree centigrade, that is 2.5. Higher resistance first I have to put at 100 degree. So we don't know R0 value. 1 plus alpha into temperature 100. Am I correct? The second, first case, if 2 is the resistance, R0 into 1 plus alpha, temperature is 25 degrees. So this is the thing we have to understand. Then dividing these two equations, what happened? 2.5 divided by 2. This R0 getting cancels. 1 plus 100 alpha divided by 1 plus 25 alpha. On cross multiplying, what happened? 2.5 into 1 plus 25 alpha is equal to 2 into 1 plus 100 alpha. That is equal to 2.5 plus 25 into 2.625. Therefore, 62.5 alpha is equal to 2 plus 200 alpha. Therefore, 200 minus 62 alpha is equal to 2.5 minus 2. That means 0.5. From which alpha can be calculated as 3.6 into 10 power minus 3 per degree centigrade. On simplification or solving, we can able to find out the value of temperature coefficient of resistance. So what is the concept? Here, this is the way. Otherwise, I have given another formula also in the regular class itself. We have discussed the same thing. What is the formula? R2 minus R1 by R1 T2 minus R2 T1. Here R2 resistance at 100 degree 2.5 minus 2, that is 0.5 by R1 T2. R1 2 into 100 minus R2 T1 2.5 into 25. That also directly we can put. Whatever is the thing, you have to understand it. What is the problem number 3? You are given 3 resistors, each of 12 ohm. What are the different equivalent resistance that can be obtained by combining all of them in various ways? In various ways means, generally I have given this problem. The various ways, how can you find out? The first way, the question is like that, what is your answer? That is the thing. If the 3 resistor connected like that, you are given a 3 resistor, each of 12 ohm. Here also 12, here also 12. Then what is the answer for this? If 3 resistors connected in series, what is the value? 3 into 12, that is equal to 36 ohm. Immediately we can put. So why I am giving a general problem? Any question may be asked. This is A. So suppose the problem is asked like that, these 3 resistors. In this way, what is the resultant value? This is also 12, this is also 12. This is. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Therefore 1 by 12 plus 1 by 12, 1 by 12. That is equal to 3 by 12 or 12 by 3, that may be 4. Are you able to understand? Here the resultant resistor 1 by R is equal to 1 by 12 plus 1 by 12 plus 1 by 12. So 12 is a LCM, 3 by 12. 1 by R is equal to 3 by 12, therefore R is equal to 12 by 3. That is equal to 4 ohms. This is the second thing you have to understand. So suppose the third argument, if the resistor is like that, what happened? So this is 12 ohm, this is 12 ohm, this is 12. So here what happened? These 2 resistors connected in series. Since they are connected in series, total resistance becomes 24. This 24 with 12, both are parallel. Are you able to follow? These 2 are resistors connected in series. they become 24. Therefore 1 by R is equal to 1 by 24 plus 1 by 12. So 12 may be an LCM, or 24 may be an LCM. That is 1 plus 2. That is 3 by 24. Therefore R is equal to 24 by 3. That is equal to 8 ohms. Are you able to follow? This is a thing we have to understand it. If the resistor are connected in this way, what will happen? So many connections I have. This is also 12, this is also 12, this is all. These two are connected in parallel. Therefore 1 by 12 plus 1 by 12. That is 2 by 12 or 12 by 2. 6 plus 12, that become 18 ohms. This is the 18 ohms. So the previous 8 ohms, here 8 ohms. How it comes 18 ohms? These two are connected in parallel. Parallel means 1 by 12 plus 1 by 12. That is 2 by 12 or 12 by 2, 16. 6 plus 12, 18 ohms. So these are the various combinations. You have to understand it. Next problem number 4. How can you find out? A battery of EM of 2 volt and internal resistance 0.1 ohm is being charged with a current of 5 ampere. In what direction will the current flow inside the battery? What is the potential difference between the two terminals of the battery? This is also very important problem. So here the internal resistance of the cell we know V is equal to E plus IR. I have given in the notes itself. That's equal to 2 plus current is 5 ampere, resistance is 0.1. That's equal to 2.5 volt. This is the voltage. Am I correct? Inside the battery, the current flows from positive terminal to negative. Actually, inside, the current flows from positive to negative. Positive to negative. That is the answer. Potential between the two terminals of the battery. The potential between the two terminals of the battery is 2.5 volt. Inside the current direction is from positive. What is the addition? The circuit, if I put the circuit the same, this is a EMF, this is a internal resistor. This is a EMF, this is internal resistor. They combine to a circuit, that is P and Q. The voltage between P and Q, the question is asked, that is called V. This V can be calculated. V is equal to E plus IR. I have calculated. And in this direction, what is the current direction? The current direction is from positive to negative. So, these are all the things we have seen in the current electricity.